afternoon, everybody. Welcome. Thank you for joining us today. We are excited for today's Let's Talk Energy. We've got some great, very knowledgeable guest speakers today. And as many of you already know, we are diving into the topic of energy integration in this webinar. What is it? What does it mean? We'll talk about real projects, important considerations. So it's going to be great. We hope that everybody gets great value out of today's discussion. Just a quick intro. My name is Megan Roney, and I'm the Business Development Manager with Toromont Power Systems, and I will be moderating the discussion today. I just want to also remind everybody that this presentation is being recorded, and that recording will be made available to all the registered attendees following the webinar today. You can find this recording and previous sessions of our Let's Talk Energy webinars on our website, as well as our YouTube channel. All right, next slide, please. So I'm just going to read through this disclaimer quickly. This presentation and the information contained herein are provided without a prejudice basis and does not constitute, nor should it be construed to constitute, legal advice or a guarantee, offer, representation, or warranty on behalf of Toromont. The panel members will be offering suggestions to several possible customer scenarios. The answers given by the panel members should be used as a guide. Okay, thanks. Next slide. All right, so we are going to begin today's webinar with a safety talk. And today we want to talk about cybersecurity. I think this is important when talking about microgrids, especially because of the interconnected nature of microgrids, right? It means that a weakness in one area can really impact the entire system. So it's important to follow basic security practices, stay vigilant, but also, you know, everyone contributes to the safety and reliability of that system. So from a physical standpoint, you know, securing that equipment and then practicing also good cyber hygiene, which I think a lot of us are familiar with, but strong passwords, using protective software, making sure that that software is updated, and so on. All right, next slide. So it's time to introduce our guest today. And I'm going to begin by introducing Chris Dorlayers. Welcome, Chris. Thanks for being here. Chris is with Toromont Cat Power Systems and is Electrical Services Manager within our Energy Solutions Group. He and the Electrical Services team support Toromont Energy Solutions for control systems, switchgear, retrofits, and hybrid systems. Chris has been working in the electrical field for 26 years, supporting the business teams using his background as an electrical engineer. And then working alongside Chris is Anthony Baz. Welcome, Anthony. Thank you for joining us. Anthony brings nearly a decade of experience in the power generation industry. He is part of the Electrical Services Group and great at helping navigate a power solution for our customers, whatever their power system needs are. He's very passionate about the future, and green technologies and energy storage is included in that. And speaking of green technologies, we have Sean Hammond with us today of Hammond Energy. Sean, thanks for being here. Thanks for joining us. Sean has followed his passion for solar energy and has been involved in over 1,500 solar projects across Canada and the US. And his focus is really on enabling commercial clients to harness sustainable, clean energy through quality solar systems and informed decision-making. After acting as VP of Operations and managing a solar operations team in Canada and the Northeastern US, he then founded his own company in 2017 and has since worked in various capacities on over 200 projects. Sean, with his expertise and experience, is really a trusted partner of Toromont, as well as our electrical services team. And last but not least, we are thrilled to have Drew from Brock University with us today. Brock has been a very loyal customer of Toromont Cat for many, many years. I've had the pleasure of spending time with Brock, and it's not hard to see why they are recognized as a leader in campus energy, a very forward-thinking group, early adopters of cogeneration. So back in 1994, they were producing their own electricity and heating and cooling. And since then have really embraced innovation and sustainability and really continue to set a standard for other institutions like them. So it is a pleasure to have Drew Collin here with us. He is the Director of Utility and Services from Brock. So thank you for being here, Drew. All right. So next slide. Now that we know a little bit more about our guest speakers, we're going to dive into the discussion, and I'm going to start with Chris. So Chris, we know that energy integration has different meanings. The interpretation of an energy integrator is different across the board. But when we're thinking about integration of an actual electrical system, the design of an electrical system, how do you define energy integration? What does it mean to be an energy integrator?
Well, thanks, Megan. Well, the energy landscape is changing, and there are many technologies that can be deployed to improve energy efficiency. As shown here, energy sources such as wind, solar, generators, energy storage can all be interconnected in what we call today a microgrid. Today, microgrid control systems attempt to help simplify this process, but often many systems require project-specific insight for proper integration. Trying to integrate them all and ensure they are delivering the intended performance can be a challenge. So, applying an end-to-end service and support concept for energy integration is an approach we would like to explore today. This means that the energy integrator is a knowledgeable about the upfront integration requirements, component coordination, system sequence of operation. In addition, the integrator holds the responsibility for ensuring that the field commissioning validates the system performance criteria. This is the foundation of the end-to-end integration concept. So to expand on this, a deep understanding of not just one, but many third-party energy sources, storage systems, and control platforms is a key component to the portfolio of qualified professionals supporting the energy integration team. Great integration protects the investment and performance commitments to stakeholders. The application of energy component technologies must be implemented in certain ways to allow maximum optimization and performance. Whether in an urban setting or a remote community, the devices being used have very specific parameters they need to operate within. Variables such as battery cycles, minimize wind curtailment, and avoiding generator wet stacking all need to be addressed. The integrator plays a critical role in ensuring the control platform manages these very important variables. So let's take an example. If we pick a topic around energy storage integration, where a project is trying to consider, should a battery energy storage system be capable of operating in a grid following or forming, or maybe both, the integrator must consider these scenarios the system may not be subject to and ensure that the configuration can conform to these requirements. Questions such as, does the battery energy storage system need to build the grid in the absence of a source like utility or generators, must then be tested against the overall control narrative. The integrator must understand what is the function of the energy storage component in the greater system. To help address this, it is often recommended to engage the integrator at this stage to help develop a specification or make provisions in the specification for these items to be addressed in a proposal. Back to you, Megan.
Great, thanks, Chris, for that overview. So that we kind of know the what, like what is an energy integrator? Can you talk a little bit about the why? Like why is an energy integrator important?
Sure. It's, energy integration, it's at the core of the system as it takes on the responsibility to understand the system performance objectives and works with component suppliers to ensure seamless management to achieve the overall project goals and investment commitments. In addition, the integrator can often provide pathways to address system improvements and future scalability. Back to you, Megan.
Great. Thanks, Chris. All right, so we're going to move on to Anthony. So can you move to the next slide, please? All right, Anthony. So can you define for us what a microgrid is? And maybe also touch on the role of different energy sources within that microgrid.
Sure. Thanks, Megan. So by now, most of us have sat through more battery electric storage and hybrid energy presentations than we can count. So we won't get into the basics of what a microgrid is today. Instead, what we're here to talk about is how all these pieces come together to deliver the best outcome. So if we think about it this way, a microgrid isn't just about having solar panels, batteries, generators, and a grid connection. It's about making them work together like a well-coordinated team. And that's where the integrator comes in. So the integrator is the one leading the charge, making sure every component is in the right position, doing the right job, at the right time. So, as Chris mentioned, whether it's a remote northern site where fuel savings are critical, or an urban facility focused on resilience and sustainability, the goals are different, but the principle is still the same. Integration drives performance. So if we take a look at the images we have on the screen, on the left is something you might see at a local rec center. On the right is a setup found in a northern community or mine site, with or without utility. Two very different environments, but the same challenge, bringing all the elements together for the best result. And here's the key takeaway. When you have a single integrator owning the design, the operation, and the outcome, you get simplicity, accountability, and peace of mind. And that's how you turn a collection of products into a powerful, reliable energy solution. Back to you, Megan.
Great. Thanks, Anthony. Thanks for that overview. Next slide, please. All right, so Chris, let's talk about switchgear. So can you kind of discuss the role of switchgear within a microgrid and maybe some potential integration considerations you may want to make?
Sure. Well, the switchgear, it often does get overlooked. And as Anthony mentioned, integration does drive performance. So today, one of the things that we want to talk about when integrating a system is the role the switchgear plays in a microgrid and just how important it becomes when multiple energy sources are connected. Think of this, the switchgear is like the traffic cop or musical conductor. Shown here, it physically connects and disconnects sources and loads as it is the common point of AC coupling for energy systems. In addition, it is the place where the energy performance is typically captured for key automation decisions. The overall control system integration often must be reviewed in conjunction with the switchgear requirements. Depending on the application and sources connected to the switchgear, specific protective options may need to be selected when formalizing the design. Take an example, local utility requirements do need to be considered when scoping out the switchgear requirements. It should be noted that when specifying the requirements for the switchgear, utility requirements should be identified as the initial step. And these are all the things that the integrator will look at to ensure is completed and that the control system and other elements of the system are matched to deliver the maximum performance. The switchgear and the high-level system control sequence for a microgrid should be reviewed always at the same time. Many times, and the other key takeaway here, is that many times the switchgear and automation may not deliver the optimum system performance when they're evaluated separately. So the key is evaluate core switchgear component along with the automation requirements. And ultimately, the scalability and future-proofing starts here at the switchgear. Back to you, Megan.
Thanks, Chris. It sounds like the switchgear is kind of like the quarterback of the system. Can you talk about from a controls perspective, describe what like the quarterback, how it's important as a quarterback of the system?
Sure. So yeah, as we were talking about a little bit earlier, the switchgear is electrically at the center of the system, and the controls are like the conductor or the traffic cop, and they help institute when breakers should operate and when loads and sources should be connected. And this is why it's so critical that when we're thinking about integration, that these two items are done at the same time or looked at the same time. Thanks.
Okay, great. Thanks, Chris. So next slide, please. All right, so Anthony, I'm going to pick your brain. Moving into generators, my favorite topic. So can you talk about generators and microgrids? We know generators are a reliable energy source, meaning it can operate any length of time. You've got battery energy storage here on the left, a genset on the right. Ensuring reliability of the system is obviously so important. So can you touch on incorporating that resiliency into a microgrid?
Sure. Those are great points, Megan. So let's walk through what we're seeing on this slide. So on the left, like you mentioned, we can see solar panels, a battery energy storage system, as well as the associated controls. This is where the clean energy comes in. These systems capture and store renewable power, helping reduce grid reliance and emissions, as we know. On the right, we see a Caterpillar genset, which remains the reliability backbone of any microgrid. Generators step up when the sun isn't shining, the batteries are low, or the grid just isn't there, like during outages, during peak demand, or in remote locations. In programs like demand response or global adjustment, generators help reduce grid usage during peak hours. That means lower costs and fewer penalties. And when needed, they can even charge batteries, keeping everything running smoothly. So to get the most out of the generator, as Chris mentioned, to avoid wet stacking, generators should run at around 70% load or higher, and that's where they're most efficient. Whether it's natural gas in the city or diesel in remote areas, it's all about finding the right balance between reliability, efficiency, and sustainability. Effective integration is what makes the system work. As Chris touched on a short moment ago, with the right controls, generators can operate seamlessly alongside renewables and storage, ensuring uptime, optimizing fuel use, and reducing emissions. A single integrator brings all these elements together, making the energy system more resilient and cost-effective. Back to you, Megan.
Thanks, Anthony. All right, can you move to the next slide? All right, so we're going to talk to Drew. Drew, we know that Brock recently implemented a battery energy storage system as part of your energy portfolio. Can you tell us a little bit about the project and some of the reasons why you implemented BESS and maybe a bit on the role that it plays within the system?
Yeah, absolutely. And thanks for having me and the introduction and the kind words. A little bit about the project. It was one of our most recent projects, part of the Low Carbon Economy Fund, which was a program from the Government of Canada designed to reduce greenhouse gas emissions and foster clean growth, investing in projects across Canada. Our goal throughout the project, like when we started the project, was to reduce our carbon emissions by around 65 to 70%. At the completion of a project, we achieved those goals. We were able to reduce our carbon emissions by 67% by the end of this project. How we achieved these results was utilizing our electric boilers and on our DES system, our district energy system. Brock back in 1964 was a fully electric campus, and it used these electric boilers as standalone boilers for heating. So in the 1980s, when natural gas became more of the mainstream fuel for heating, the electric boilers weren't being used anymore. However, we've revitalized them and brought them back into play, and now we're using them to support the district loop with heating and supplying the BTUs needed with direct connections from the electric boiler systems in these mechanic rooms into the district loop. So pre-DES electrification, we used our cogen plant. So our cogen plant is made up of 4 2-megawatt Caterpillar 3516Hs gensets. Brock not only depends on the cogen for electricity generation, but prior to the electrification project, it was our primary source of heating for the campus when we're kind of a trigen, as we use that heat in the summer for absorption chilling, so we can provide enough heat to produce 1,000 tons of cooling on campus in the summer months. Our new operations now plan to run 1 engine versus our two engine minimum, which we were running pre-electrification project. The cogen also provides us with the resiliency in a power outage, which is the reason we ran these 2 engines. We use the cogen plant to power all our critical buildings on our campus by islanding the plant. Critical buildings, some of the equipment in these critical buildings do not like a change in power or delay in power in an outage. So we island the plant so it doesn't see those type of outages and no loss of power or change. And so that's where the battery energy storage system came in, or the BESS came into play. To run 1 engine, we had to provide 2.5 megawatts of electricity because that's the electrical demand for the critical buildings. You can't do that with 1 engine. So we implemented or installed a 500 kilowatt BESS system to run in the event of an outage and support the 1 engine meeting the electrical demand of the buildings while allowing that second engine to come on in our automation protocol. Without the BESS, we wouldn't have been able to run 1 engine and therefore not meet the goals of the project, would have been the carbon reduction. So the BESS was imperative for this project for the success. Back to you, Megan.
Thanks, Drew. That's very impressive. All right, so now we're going to take a look at another project. So can you move to the next slide? All right, so this question. Oh, sorry, we're getting background noise there. Sean, it's directed at Sean. Can you tell us a little bit about the solar project? Maybe give us an overview just of the solar implementation with the switchgear and other energy sources that you had here.
Yeah, thanks, Megan. In this example, our client is a plastics manufacturer, and they feed into the automotive industry. They're seeking guidance on how to meet their goals for reducing their carbon footprint and utilizing existing roof space to produce electricity with solar. So they have a fairly heavy electrical consumption and a relatively high Class B electrical bill. So after 25 years in business, the founding team reached out to us to see if there's any way we could help them figure out a solution for their facility. The main technical priorities included they wanted to do the largest possible PV generator while limiting any upgrades to the facility if at all possible. So we started by kind of trying to figure out which of the following 3 criteria would dictate that. Number 1 was available roof space, and to determine that, you can see a good before and after in the slide. We use a 3D software that's fed from drone images, so we get a really highly accurate survey of a building. We can do a 3D model to figure out exactly what fits with obstructions and whatnot. Second was their annual consumption. So we don't want to produce more than what's needed on site, depending on how much that roof would produce. Third criteria was, of course, not upgrading any of their existing electrical equipment or transformer on site if we could avoid it. So we looked at the customer's annual usage and determined that the whole roof filled with solar would cover about 40% of their annual requirements. So we figured that the whole roof could be used if the other criteria were met. So we did a survey on site. They have an existing switchgear that's got a 1,000 amp bus and an 800 amp main breaker. And there's some code requirements there around connecting generation to switchgear. That meant we would be able to connect a maximum of 400 amps of generation up to 600 volts. So that might be a limiting point. We were able to work with our integration team to come up with a pretty neat setup that utilized a bus protection relay and breaker that integrated with SCADA requirements that Electra had for us. And we could then use the full potential of the system on the roof while protecting the existing equipment. So we were able to build this system, avoid any major upgrades. So in our industry, it's really cost sensitive. We're competing with other sources of power like the utility power and trying to find a cheaper alternative. So this allowed us to install a sort of max size, max benefit at lowest cost of electricity for the client. Using a cool strategy to protect the bus and keep the existing switchgear in place.
Yeah. What are those?
Oh, sorry, we're getting some.
Yeah. Okay.
Just don't mind muting yourself if you're unmuted. We'd appreciate it. Sorry to interrupt. Sean, do you have anything you want to add on that, or were you finished?
The only other major thing here was that we were able to provide some really cool insight into the consumption for the client. So in doing this, just like a nice byproduct of going solar for them was the equipment we installed gives them really good, minute by minute insight into how they're consuming power, how they're generating power, their import and export situation, to provide them, good guidance if they're going to make any other energy-related decisions at the plant. So,
awesome.
Yeah, back to you.
Very cool. Thanks, Sean. And Drew. I mean, it's always great to see real projects instead of just talking hypothetically. So, appreciate you both sharing those projects with us. So we'll move to the next slide. Kind of dovetailing off of Sean and solar integration, Chris. Oftentimes, we don't get to start from scratch, meaning you have a customer, they have an existing system, and as an integrator, you're now having to augment that system to add renewables. Obviously, there needs to be some considerations made to ensure that the project is successful. So can you talk about the most important things you need to consider when it comes to dealing with an existing system?
Sure. Yeah, so, oftentimes when we think about topics like battery energy storage, renewables, we do often think about greenfield projects, new systems, in general, a clean slate. But in reality, many of the energy improvements come from existing systems and updating them to include new energy technologies. So let's break this down and look at the considerations to make when integrating energy sources into existing systems as depicted in the images here, left to right. Just as a quick note, much of the considerations shown today refer to electrical components, but the mechanical components of an energy system should also equally be evaluated when working with existing systems. So, the very first thing that you want to do if you're considering doing something with an existing system is look at the age and potential obsolescence of the components. So if we go back to the switchgear conversation, let's use a switchgear as an example. We did kind of say it was at the core of many of these energy systems. So that's a good place to start to see if there's obsolescence. In a switchgear, you may have components like, a protection relay, a PLC, breakers, and all of these items are subject to being obsolete. So the best thing to do out of the gate is to evaluate all of those components to make sure they are not obsolete. And if they are, then you work up a plan to do a replacement. And I'll go back to the integration discussion and the fact that when you're looking at this and you're looking at potentially doing a retrofit, you want to also take all of those obsolete parts and put it in conjunction with the rest of the system. Because oftentimes, if you go to upgrade a component in a particular section like a switchgear, there may be downstream other upgrades that need to be affected. You might be altering the communications as you do an upgrade, and now it no longer works to upstream components. So again, a system end-to-end approach is required. So that the very first thing is always to capture those obsolescence requirements. The reality is investment returns may be short-lived if obsolete components or even code compliancy issues are found after the fact. Then next, as we kind of think about the system, this is before we're actually putting and applying renewables or energy source. What other things should be incrementally done to that existing system? And the reason you want to do that is if you're going to work in the realm of existing equipment, you want to make sure that you look at the life cycle of that equipment and increase the age of that. So you want to extend the life of the equipment. So, maybe things aren't obsolete, but there may be things that you want to upgrade so that life is extended. Maybe there's a 10-year life cycle that you want to extend that energy system to. So after you've addressed the obsolescence, you're going through and making sure that you've got your life extension to the time frame that you want. So after that, after the obsolescence and incremental changes have been evaluated, the system now can be further evaluated to see what needs to be added for successful integration of energy sources, whether it be renewables or a battery energy storage system. And as you do that, if I think back to the conversation Sean Hammond was having, he mentioned switchgear and things that needed to be incrementally added to support adding solar. There may be protection elements that need to be effectively worked in, other elements to comply to local utilities. These are all things that need to be added in order to allow the system to participate in adding renewables. So that's a bit of an example of small upgrades. And at this moment of time, I want to also make note of the fact that, retrofits do offer a potential alternative when they make sense, i.e. there's, you can address the obsolescence, there's lots of life left in the equipment, to replacements. And the reason that is oftentimes if you think about the switchgear example again, if you don't have to remove a switchgear, then you're not worried about yanking cables. There's no such thing as cable stretchers. And therefore, they can oftentimes be a great, investment bolstering your investment. And in other words, you're going to reduce the cost to implement adding renewables by doing the retrofit. Something else to consider when we're looking at, upgrading or integrating renewables into existing systems, and there's a term that probably many have heard, and that is making the equipment renewable ready. So in this realm, what you want to think about is maybe you're not ready to make the complete investment in adding a battery energy storage and maybe or renewables, but you want to ensure that the equipment has lots of life. You've done the retrofit, and as you're doing that retrofit, one of the things to consider baking into that retrofit is ensuring, equipment like generators, the switchgear, as we talked about, they're all capable of now intercepting future renewable or energy storage systems. And, some of these things might mean the controls are set up so that they can intercept or are capable of communicating with other control elements that handle renewables and battery energy storage. So these are just some of the things to consider when working with existing systems and adding renewable and energy storage. Back to you, Megan.
Thanks, Chris. That was excellent. Very informative. All right, next slide. Okay, so we have evaluated some key considerations around the actual integration, but I'd like to get Anthony's perspective on the topic of the actual customer. So Anthony, in your experience, when it comes to the customer that you're providing a solution for, can you talk about their expectations? Meaning, they care, what do they care about the most? Is it just keeping the lights on, or does it often go beyond that?
That's a great point, Megan. So what customers really care about when it comes to energy integration and microgrids, and how having an integrator helps. So there's 3 buckets. So first are the non-negotiables, reliability, compliance, and safety. So these are the baseline requirements, and the integrator ensures all moving parts come together to deliver on them effectively. So next would be the value adds, lower energy costs, green solutions like solar and storage, and scalability for future growth, as Chris has mentioned too. Integration ensures that these aren't just buzzwords, they're real and measurable benefits of a microgrid. So finally, the experience, seamless integration of new and existing assets, smart controls for easy operation, and transparency with real-time monitoring and ROI, which Sean had touched on. That's where a single integrator shines, owning the design, the controls, and the outcome. As mentioned by Chris earlier in the presentation, it doesn't stop at commissioning. Integrators handle training, lifecycle management, and making sure the team understands how everything works together for peak performance. In short, integrators don't just deliver a system, they deliver confidence. Back to you, Megan.
Great. Thanks, Anthony. All right, next slide, please. All right, so this question is for Drew. Drew, can you talk a little bit about maybe any lessons learned from implementing the BESS? Meaning, like, is there considerations you can think of that one may want to, think about before they actually go through with the BESS project, or things that maybe like the utility, dealing with utilities, or maybe some bumps that you ran into that, you want to maybe highlight? That would be great.
Yeah, 100%. Really the BESS, or the battery, was the most complex part of this project. When you're putting a battery in, you got to define the purpose. So you really want to just, are we using it as a support system, emergency? How long are you going to be discharging it? Like, what is that scope of work that you're installing for? And then you're looking at, that's going to lead you into what type and size. I was really surprised to knowing that like a 500 kilowatt hour battery would only give me 20 to 30 minutes at full discharge to get my second engine up and running. So really knowing how long you need that to run for in order to complement your system. Do you have the proper infrastructure in place? That could really hurt a project if you didn't have the proper infrastructure in place, purchasing a battery, and then you have to upgrade and upsize a lot of your infrastructure to meet the battery's requirements. As you said about the utility, yeah, you better look at your connection agreement and talk to your local distributed company. See what rules and measures they have in place and see what your contract says and what's defined in that. In Brock's case, we weren't allowed to generate or export to the grid. So we had to do a test, record, and prove that the battery would shut down within 100 milliseconds of the breaker closing to the utility. So having to do making sure that we had the proper equipment, protection relays in place and that they would respond was really imperative to if this was going to work or not. And everything was already in place. The location, do you want to put it on a roof? Where do you want it outside, like on the ground? Like we chose the ground. One of our life safety personnel said, what if there's a fire? How are you going to access it? Battery fires are sometimes hard to deal with. So do you really want it on the roof? So looking at that and looking where you're going to tie in is super important. And then the network infrastructure. So if you're tying this into your SCADA system and with the Tormont system, the Caterpillar system into your MCP, and you're going to have everything working together and communicating together, how is this going to work? What kind of network communication are you going to use? Are you going to be using Modbus? Are you in the control sequences? What needs to talk to what in order for it to work? And there's so many moving parts when you're talking about a battery supporting the engines coming on, your SCADA system is working one, your PLC is working the other, your controller in the battery is doing the other, and they're all working together for one common objective. So it was had a complexity in itself, and then the control sequencing. So these control sequences were super sophisticated. Brock had to develop all new sequences that complemented the engines because we already had auto stop and start with the engines. We already had things in place how the original plant ran. So we had to incorporate that battery sequencing into it and ensure it worked. So it was quite interesting to do. A lot of testing went along with that when it was going to be armed and disarmed, and then when the second engine would come on. So all these factors contributing into just one part of one project, but with a huge outcome because it allowed the project to be as successful as it was. So, those are a few highlights that I would say are key when looking at installing a battery system.
Awesome. Yeah. Thanks, Drew. Appreciate that. All right. So next slide, please. So last question for today to our panelists, and I'm going to throw this one to Sean. Similar kind of theme, Sean, in terms of, considerations. So when we're touching on, when you're evaluating or maybe implementing a solar project, can you talk about the same thing as Drew? Like, what are some maybe things you need to think about before you proceed?
The money. It's funny with solar, it all seems to come down to, or often come down to levelized cost of electricity. So like I mentioned earlier, we're always competing with other energy sources. And this is where, as an integrator, your approach, your strategy to get that levelized cost of electricity down, you're looking at a 25 to 30 year financial model typically. And you take all the capital costs, all the operational costs, and those operational costs are often where, a little extra capital up front into important things like control systems, future proofing, just quality install, those sort of things help lower your operation cost over the life, help keep your levelized cost of electricity down. Another big one that factors into the LCOE is incentives. So solar is typically leaning on some incentives to help make a business case. So, for example, right now, if you're an incorporated business in the province of Ontario, you typically utilize three main streams, kind of applicable to all incorporated businesses, and then there's additional ones. The largest of those three, where it's applicable, is the Save on Energy retrofit program for renewables, and that's a strategy that requires solar to be a load displacement connection with the utility, and therefore it requires controls, export limiting, utilizing the equipment that we've talked about here so far. And we're attacking demand more than kilowatt hours typically in that argument. The federal government's also offering a 20% investment tax credit that can increase up to 30% if prevailing wage labor is used. So it's federal through the CRA. In addition to that, you can use an accelerated capital cost allowance. So if you stack these three, those are pretty important aspects. Other big factors that affect that cost, the local distribution company or your utility in Ontario can vary quite a bit in their approach. So there's over 60 utilities in Ontario that we deal with to connect solar, and each one deals with solar a little bit differently. So the approach they take, the testing requirements, the SCADA, the protections, and the costs, like the connection cost, their connection fee, can really make a dent in a project from a viability standpoint. Even just the utility rate class A or Class B, or general service, subtransmission, and how that's administered by the local utility in determining the cost of electricity we're trying to replace. And then more technical things like we've discussed here, roof space, the type of roof we're using. A good example, best example I can think of for a roof, if a building has a sloped steel roof, especially a standing seam roof that we could clamp onto, that is probably an example of the least expensive means of mounting solar on a roof. If it's a flat roof, we would use a ballasted racking. There's the added cost and weight of ballasting. If you don't have to work around obstructions as much, so the cost of the system's often impacted directly by the type of roof, the roof space, and then electrical tie-in, which we talked about. And these two photos or the two images on the slide are kind of, on the left is an example of how we're tying in, protecting a switchgear, how that would typically look in an installation at an average light industrial manufacturer in Ontario. So how inexpensive is our connection cost? And the best example of a cost-saving opportunity there, if one facility has a 208 volt infrastructure and the other has a 600 volt infrastructure, the 600 volt site is going to be way less expensive on the electrical side and inverter side to connect solar. So yeah, to get your costs down, incentives, the LDC and the utility rate class they use, roof space and electrical tie-in are kind of the main integration considerations for us. And we've been learning, almost week by week this year, there's some really neat strategies you can deploy, and it makes a huge swing in the financial return. So you've got to be talking to people who know what they're talking about.
Yeah, so true. So true. Yeah. Thanks, Sean. All right, next slide, please. Okay, so we are now going to move into the Q&A portion of the webinar. So please don't be shy. Feel free to submit a question using the chat function, Q&A at the top. And we're happy to answer any questions that you have. And if we don't get to it or you don't want to ask on the webinar, you can email me, mroney@tormont.com on the screen, and we'd be happy to get back to you after the webinar. So we did get a question for Anthony, And the question is, could you elaborate more on the generator working capacity with the best efficiency? Can it run at its 100% capacity?
Yes, that's a great question. So technically, yes, a generator can run at 100% capacity, uh, but that's not quite ideal for long-term use. The best efficiency, as we kind of mentioned in the webinar, is typically around the 70 to 85% load. That's where fuel use, wear, and performance are all optimized. So when an integrator is sizing a generator for a microgrid, the balance is struck between not having the generator maxed out, not having it underloaded. And an integrator would take all these aspects into account when reviewing the system for the best reliability, efficiency, and overall performance. So yeah, back to you, Megan.
Awesome. Okay. And then I have a question for Sean. Does solar work when the utility fails?
Historically, the answer's been no, but in this conversation, if by design, and sorry, back to the reason being, when solar is grid tied, if there's a power outage, there might be power line workers, you know, doing a repair on the lines, and the system is designed to shut off to protect them. In the case of a microgrid, though, that system could be designed to operate without the grid connection. So if I'm working with Tormont to design something with PV, we would typically be integrating a BESS and generator in that overall strategy. And in that case, solar would be seeing its grid reference that it needs to operate from the BESS. And the controls that Tormont would implement would, for example, give the grid reference. So it's typically no, just a simple grid-tied solar system. No, it doesn't operate when the lights go out. But if by design, that's been incorporated, then yes, it can.
Okay, great. Thank you. All right, next question. Chris, I'm going to send this one to you. Can a battery energy storage system operate without a microgrid controller?
Oh, thanks, Megan. Well, the simple answer is yes, it can. So oftentimes, when people think about battery energy storage and tying it to maybe utility and doing something, battery energy storage does have onboard controls already to be able to discharge and charge that battery. However, similar to what Sean mentions, if we start to look into kind of a microgrid concept, where now you have multiple sources. So let's take, for example, a generator, solar, and battery energy storage system. Now, and let's say you're off grid, now the whole purpose changes. And this is kind of, again, getting back to integration. The goal in that particular instance is to reduce fuel consumption on the generator. So the microgrid controller, in this instance, is kind of an overarching control platform that will, ensure that all of these sources are operating to achieve the maximum performance, kind of like when we first were talking about, the importance of an integrator. And so that would be why you would need a microgrid controller, and why you don't need a microgrid controller in certain cases.
Awesome.
Thanks,
Okay.
Megan. Back to you.
Thanks. I like this question. I'm going to ask Anthony this. So does Tormont have a mobile microgrid?
That's a great question. So yes, we do. So Tormont offers a mobile microgrid solution that combines a generator set with a battery electric storage system on a trailer. So it's fully transportable. And we can also integrate solar generation for added sustainability. So the setup is available through our rental fleet, and gives customers great flexibility, and it's a great turnkey solution for temporary or remote power needs. That answers your question, Megan.
It does. Thank you. Thanks, Anthony. All right. So I think I don't see any more questions that came through the email or the Q&A function. So that concludes the webinar today. I just want to say thank you so much to our guest speakers, Drew Cullen and Sean Hammond. It was a pleasure. I learned a lot. Thank you so much for sharing those projects, their information and considerations, and talking about your projects with us, because it's really helpful for everyone. Also want to say thank you to Chris and Anthony, for my fellow colleagues, for participating and enlightening us on some really important key things when it comes to integration. And hope everyone on the call really enjoyed the webinar. Hope you got a lot of value out of it. We will be hosting another Let's Talk Energy coming up, so we will keep you informed. Be sure to register. And again, if you have any questions, please don't hesitate to reach out. We're happy to help. Shoot me an email. That would be great. Have a wonderful afternoon, everybody. Thanks again. Take care. Bye-bye.